Great. Hello and welcome to a very exciting fourth edition of the UBTECH AI webinar series. Excuse me. So we're really excited to get started, and jump in to talk about how we can integrate AI into your classroom. So just to dive right in, once again, my name is Rusty Nye. I'm coming to you from my home in Southern California. I am the implementation manager for UBTECH Robotics. So if this is your first time to join this webinar series, once again, this is the fourth in a series of 5. UBTECH is one of the world leaders in developing AI and robotic solutions. So we build robots for businesses, for the household, and also for the classroom. So I'm coming directly from UBTECH Education, where we are developing a full integrated AI curriculum for the classroom. So we're developing our curriculum focused around AI for K-12's 5 big ideas. So the first 3 webinars that we developed focused on the first 3 big ideas. We're going to be jumping today into the 4th big idea of natural interaction. So without further ado, I invited my friend Tim to help kind of lead and integrate and talk through some of these ideas with me. So Tim, sitting there like you at home, may think, what the heck are we talking about by natural interaction? That doesn't seem like a very CS computer science term. What do we mean by that? So in essence, intelligent computers or AI agents require a lot of information in order to interact with humans. We interact with robotics, with computers, with all sort of technology every day. AI, in essence, has a huge impact on the way we can interact with these different devices. So I'm going to dive in to how, in essence, what we mean by this interaction, how AI is going to help revolutionize this idea of interacting with computers. And I'm going to give you guys some tools and some examples and projects that you can take into the classroom to show and work with students to highlight some of these ideas of natural interaction. Before I dive too deeply, I do want to remind you that we have some of our UBTECH staff, some of our experts in the chat room. So if you guys have any questions, comments along the way, feel free to drop something in the chat, and Julie and Christina, my colleagues in UBTECH Education, will help try to answer any of your questions. I'll also remind you that we're currently recording this webinar, and we'll be hosting this on our website after we finish, of course. So great. Before we can really start diving into some of the concepts and giving some examples of AI and natural interaction, I always like to focus on doing a quick comparison. So, what do we really mean by natural interaction? So first, before that, let's look at Tim. What can we tell about Tim just by looking at this image? And also, this is something I would like to do, or I have done with students, to kind of set the tone for how we're talking about our interaction with computers. Throughout these slides, I will be speaking in, generalized method about how, in terms of working with students, what you can say, what you can bring into the classroom. So, feel free to take down some of the ideas that, I possess and bring them into your classroom. So if we're looking at Tim, what can we tell? Is Tim happy or is Tim sad? So, in general, we see Tim has a smile on his face. So inherently, we know as humans, we're ingrained to know that a smile generally is going to mean that Tim is happy, right? So Tim, are you in a good mood? Oh, great. So Tim is super happy. That's great. So we were able to infer correctly just by looking at Tim that Tim was happy. So let's switch in and look at Yanshi. So once again, Yanshi is our humanoid robot for educational uses. And what can we tell by Yanshi just by looking at him? Is Yanshi happy? Is Yanshi sad? So of course, Yanshi is not a sentient being. He's not, doesn't possess any emotions. He's just a machine. He's a robot. So just theoretically speaking, what can we tell? Well, would you guys be impressed to know that Yanshi actually is super happy? So of course he's not actually super happy, but the main point that we're trying to make here is that in order for us to perceive and interact and understand machines, they have to be programmed in order for us to interact with them. So you might be saying, okay, that's not that revolutionary in terms of what we're talking about, right, Rusty? We all know that robots are different than humans. There's nothing new about that. So why are we even making this comparison? What are we talking about? So the reason that we're making this comparison is that AI, as a progression in technology, can make these interactions easier and more human-like. For example, Yanshi was able to understand and respond to Tim's inquiry, about what we're talking about that. And that might, shock, Tim just a little bit. I hope you guys like my animation that I put in there. So the main concept that we're trying to focus on here is that AI, as a technology, intelligent agents, enable computers to be more human-like. They enable them to be more integrated and interact with humans on a more humanistic level. And as we'll dive into some of the examples, you'll keep seeing that AI, as it keeps progressing and becoming more ingrained in our societies and our daily lives and more advanced, it's going to continue to make computers more and more human-like. So great. So, what are some connections and examples that we can, make that, students can actually see? So one that I always like to touch on that it is revolutionizing our daily life is this idea of ingrained facial recognition. So you might have seen facial recognition on your cell phone to unlock your phone. You might see that some, airports, for example, are integrating this at their self-service check-in kiosks. So, how does this relate to natural interaction? So in this example of a kiosk at an airport, an individual could walk up, insert its passport, and then the computer itself would be able to verify that passport matches the person's face in front of them. So this progression, this interaction between the human and the computer becomes a lot more streamlined and inherently a lot more progressive and a lot easier for a human to interact with. So if you want, an example, let's bring it back to robotics for a second. What are examples of this facial recognition technology being implemented into robots itself? So, Yanshi just kind of showed up there. So Yanshi, who I actually have just sitting with me right here, and if you guys want to look away from my slide, Yanshi is about, a foot tall, and Yanshi actually is ingrained and embedded with facial recognition technology. So we can actually program Yanshi to recognize, a particular person's face and then respond to what it recognizes. So this is an example of just being able to utilize that idea, that technology, into something that we can really bring into the classroom. And as you'll see, as AI becomes more ingrained into our devices, into our technology, this idea of facial recognition will continue to make interactions with computers a lot more, acceptable and a lot easier for us to see. So I know that that's kind of an overarching concept. What is another concept and another example of natural interaction that we come in contact with? So a huge turning point in AI is this idea of natural language processing. So you might have heard this abbreviated as NLP. This is a huge pivotal concept and area of AI that's been able to really impact how we interact with computers. So what is natural language processing? So, we can basically, define NLP as the interaction between humans and computers through the use of language. So if you'll see on the screen, I actually pulled out images of Walker, our humanoid walking robot at UBTECH, and also Cruiser, our service robot. Both of these robots are ingrained and have NLP systems within them. So NLP is able to recognize audio, text, or different sorts of interactions in terms of language. So what are examples that we come in contact with NLP? So I pulled out just some, basic ones that you probably have had context with or interaction with, probably even today. So search engines, they're able for example, Google is able to understand what you're putting in to the search bar and make connections to what you're trying to search for in real time. This is an example of taking a piece of language and then associating that with all different places on the internet, so these being different websites. In addition, translators. So also Google Translate has a really advanced system that's able to understand text language as well as speech language. And we even have some real-time translators that are able, you're able to take on a trip with you to help you translate, say, at a market or something similar. So in addition, we also have smart assistants. So what's an example of a smart assistant? Maybe Alexa you have in your home, which can understand your voice and then make a decision, based on what you're saying, to the device itself. Also, a more primitive, if you will, example of NLP would be predictive text. So you can see this, when you're working in Microsoft Word or in your Gmail account. You can type something and then it can predict the rest of the word that you're trying to type. This is an example of the computer system being able to understand, by looking at different examples that you're probably trying to get to this area of the word or this sentence. And then lastly, chatbots, which we'll actually build one in a moment. So these are just quick examples. We actually come in contact with NLP all the time. And this is actually something that's inherently hard for computers to do. And so this is something that AI has really been able to help computers move to this next level of understanding language and text. Great. So what are some fun examples you could do at home or, bring into the classroom? So a very simple one, you can utilize your smartphone to ask Siri. So I actually have my smartphone next to me. So I'm not actually going to say this phrase on the screen because otherwise my phone will hear me say that and you'll hear a response. So this is a fun example in that Siri provides a very natural interaction with your smartphone. If you notice, you can talk to Siri, you can ask Siri different questions, and Siri can be activated just by saying this specific phrase on the screen. This is a great example of NLP being brought into everyday use and making technology very interactive and natural, very easy for humans to engage with. So if we want to talk a little bit more about Siri, this is something I like to do, especially with students, is let's go ahead and compare and contrast, the strengths and weaknesses of this kind of technology. So what strengths does Siri have? So just in general, we can say Siri is very strong at understanding the user that has the phone. And why is that, you might say? So last week we learned about how computers are able to learn from data. So Siri has actually been trained, your device has been trained on your voice. So when you first get your phone, it asks you to repeat several phrases, say that phrase that I don't want to say, otherwise my phone will unlock. But it understands you in that context. That's because it's been trained on that data set of your specific voice. In contrast, some of the weaknesses of Siri is understanding someone else. So this means if Siri was not trained on another person's voice, then it may not understand that other person as much as it understands you. For example, you can try to kind of mix Siri or, confuse Siri by speaking in a funny accent. This is something students, of course, like to do. So kind of as a fun first activity to dive into some of these concepts of NLP, I always suggest trying to test the limitations of Siri. So highlight what are the strengths, what questions can Siri answer correctly, what kind of information can she provide to the user very, very quickly, and then try purposely to try to confuse Siri and note what confuses Siri and why. And usually what you'll see is that it will be limited data that Siri is able to reference against. So all that idea of back to every time you talk to Siri, Siri is able to learn something new. And if you're putting something that Siri may not has been able to been exposed to or hasn't learned before, you may be confusing Siri. So great. So if you're looking for some projects, I'm going to very quickly show you how we can build a very primitive chatbot using our UCode software. And then from there, I'm going to kind of highlight and turn to a different program and show you how you can help, elaborate on some of this machine learning concepts by focusing on a program called Machine Learning for Kids. Great. So let's go ahead and just kind of dive in. So here you can see this is UCode. So this is UBTECH's proprietary software environment for building and communicating with our robots. So as you can see, it's formatted and developed to look very similar and have a lot of the interaction to Scratch. As you can see, like the Scratch, cat, that we have our own little guy named Yuko. So basically what we're going to do is we're going to build a very quick chatbot in order for us to interact and communicate with Yuko here. So I'm just going to start by pulling in some blocks. So it's very similar as I mentioned to Scratch, in that we have a lot of the same blocks. So let's first say when I click the green arrow, when I activate my program, we're going to first let's just say we'll greet the customer, or customer, I should say, the user. So then Yuko is going to ask us a question. And let's go ahead and ask, how are you doing today? But this is where we're going to kind of pull back. We're going to say and limit it to an A-B response. So it meaning that the answer should be one or the other. And so let's go ahead and say good or bad. So then we want to pull in some different control blocks. So let's go ahead and pull in two different if-then statements. And then we need to put in some operators. So, and here we're going to say, if we answer good, Yuko will respond with a certain action or certain message. If we respond with bad, Yuko will respond with a different message. So let's say, what do we want Yuko to say? When he or she says, when you respond with good, they will say great. Conversely, respond bad, say, oh, that's too bad. So let's go ahead and test this very generalized quick chatbot. So let's see. If I type in good, of course, Yuko should respond with great, right? And then conversely, if I tap bad, great. So as you can see, this is very simplified. So basically we're saying, you know, is it this or is it that? And then our computer is going to respond either direction. So as you can see, this is very simplified. Does this utilize AI? So it does not, but it does simplify and give an example of an interaction in a response, you know, utilizing a computer system. So how could we make this more advanced or ingrain some sort of AI? So what we could do is look at these operator blocks, right? So what we're saying here is it's just a one choice, right? It's just good or bad. How could we try to create something that is able for you code to decipher and make meaning of what you're trying to say? So this is where we can look at machine learning for kids. So if you're not familiar with machine learning for kids, this is a great program developed by Dale Lane, actually a software developer with IBM. So this is a great way for students to build machine learning data sets, you know, that are very easy and utilize them for all different projects. So what we would simply do here, and I already created this because it does take some time, but I basically created where we have here good and bad. So it's just one or the other. I use that same network to create two different buckets. So I created a bucket of all different words that are associated with good, different words that are associated with bad. And you can see I only used 10 examples. So what we're going to do is we're going to train a machine learning model to utilize these different 10 examples, compare them to all different examples associated with these words on IBM's Watson. So a huge data set of all different reference points that they're going to go, you know, connect to. So what I can do here is first I would build the, you know, the different examples here. You can actually build up to 1,000 different, you know, examples if you want. And, you know, I should say I'm moving really quickly because I know we only have a few minutes left to give you examples. This software also recognizes images, numbers, even sounds. We could spend, you know, days playing with this piece of software, but this is just a quick example that I want to move through and just highlight quickly. After we create our example buckets, then what we can do is train it. So this is basically, and as you can see, I trained it, you know, 20 minutes ago. And this basically is connecting to the IBM Watson server and running against those different examples. So then I can test to see how well it's going to recognize, you know, if this sentence I put in would fit in one category or another category. So let's say, you know, I'm well. So this recognized that it would fit into that good bucket with 96% confidence. So it is also able to put out a confidence rating, which is pretty good. So what you can do from there is you can actually open up these blocks into Scratch 3.0. So as I mentioned, UCode is actually developed to look, you know, the same as Scratch. So you can see how we can move, you know, directly into a program that looks very similar to UCode. So let's go ahead and really quickly, we will build a very similar or you know, more or less the same chatbot, but we're going to replace those good and bad labels with varied machine learning models. So instead of saying good or bad, one or the option, let's say, how are you doing? So once again, let's put two of those if-then statements. Let's move in, let's put the same operators here. And then let's say, so if it falls into this good statement, let's just say great. And if it falls into the bad area, let's say, no, not, oh, that's too bad. So here's where it's a little different. So then we're also able to recognize and look that we have specific machine learning blocks. So where we train that model, we're actually able to drop that in to our operator here. And if you'll see, we have a block that's recognizing it in the category of good. We also have it, whoops, and I'll show you how to utilize the confidence rating as well as bad. So once again, we need to put in our answer blocks. So let's go ahead and test this. So remember, we don't have to say just good or bad, but how are you doing today? I'm fine, a little tired, but all in all, just fine. So great, it was able to read that, that fit by probably recognizing that word fine is associated with other words in that category of good. So one other thing I wanted that you guys can note that you can build into this, this particular program is we can also build in those confidence scores as well. So let's go ahead, we should set first we need to make a block called confidence, and then we can set our confidence to 0. Let's change our confidence based on what we're responding to. We'll say that it's going to recognize a confidence of good. So is this something that you guys feel that would be fun to utilize in the classroom? Probably, right? So let's say, if you can see the confidence score already changed to 0. So the Scratch Cat's asking me, how am I doing today? Let's give it a, I'm actually doing pretty good. I feel great. I'm happy to be here. So I'm gonna lie, but I'm gonna say, I feel a little sick. How about that? I feel a little sick. Oh, that's too bad. Oh, with a confidence rating of 100. So it definitely puts sick into that category as feeling negative or bad. So you can continue to build, on this idea, and you can incorporate this in all sorts of projects, within Scratch as well. If you wanted to keep going in UCode, what's something fun you could definitely do is connect this layer. You could keep going with different questions. You could try to build out a whole different scenario where you could interact with UCode, which you can also connect to your robot as well. So for example, you could dive in and put in some of these explore blocks, which are directly connected to the robot that you can build. So, you could say something like, if you respond with good, you could definitely change the color on your robot's LED, or you can, move different servo motors and have your robot interact differently. Great. So I know that's a lot to kind of soak in, and I'm moving very quickly, so I apologize for that. I love really playing with different programs that explore AI, especially for kids. But let's go ahead and summarize some of what we talked about today. I'll give you some takeaway points, and then we'll talk about, where we're going from here. So one of the main key ideas that we want to relay to students in terms of natural interaction is that AI enables computers, AI technology, AI agents, enable computers to interact with humans on a more natural level than ever before, if you will. I think it's really important to first identify the strengths and the weaknesses of current technology. we actually see these ideas and examples of natural interaction every day when we interact with AI technology. For example, natural language processing is something that the majority of us interact with, daily, many times a day. Facial recognition, and try to identify all of those ideas of how we interact with computers and how naturally they are progressively becoming. We can utilize these ideas, to help build different chatbots, and we can help demonstrate this idea of how humans can interact with computers and how inherently AI can help make those interactions, more positive, more unique, and more natural. And you can utilize all these ideas to build really, really awesome robots. This is something we see teachers and utilizing all over the country, how they can utilize these ideas, these concepts to make robots that are very human-like in terms of the way they interact. So great. That's kind of summing it all up. And wow, I'm have one more minute or so. So let's go ahead and thank Tim. I appreciate Tim sitting in, helping me lead some of these, even though he's a little sarcastic, he does kind of help me, drive some of these talking points. And he is reminding us that, we'd like to do this again. So we're going to have our 5th webinar concluding this series of AI webinars next week, the same time, the same place. This will be led by my awesome colleague, Julie, who will be talking about the societal impacts of AI technology. Also, in addition, you guys can visit ubtecheducation.com /home learning to see all of these webinar recordings. You can access our PowerPoint decks. We'll be including them there. And you can also see some of the other activities that we're helping support a lot of the at-home initiatives. In addition, something I do want to relay is we are also creating a more long-term interactive AI professional development session for educators that want to try to bring AI into their classroom. So really stay tuned for that. That's going to be something that's really fun that myself and the team are going to be hosting, where you guys can actually, utilize a lot of these tools, and we can help you integrate these directly into your classroom through interactions with myself and our awesome team. So I really appreciate those that were able to, chime in. I did see you guys have some great conversations on the, in the chat bar. So appreciate everybody for joining. Everyone have a great day wherever you are, and I look forward to meeting with everyone very soon.